We're going to combine two sections, 5.2 and 5.6, into one set of video notes, which will cover dividing polynomials. First up, long division. This is the more complicated of the two methods that we'll cover in this section, although there are some problems where you have to use this method. So to start, let's write it in the mathematical divisor formula with what we're dividing on the inside and what we're dividing by on the outside. Okay, also note that we want to make sure that all our exponents, okay, are represented descending from our highest exponent. So we had an x to the fourth, we had an x cubed. There wasn't an x squared here, which is why I put in a 0x squared. Okay, then we had an x to the first and then x to the 0. Okay, if you skip any exponents, you have to put a 0x squared or a 0 whatever exponent that is into the problem. So the whole idea in long division is we want to get these first terms to match each other. So we want to turn this x squared into a 2x to the fourth. And we do that just by multiplying it by a monomial. So to make this match, we would need to multiply it by a 2x squared. Okay, and when we do that and we distribute it in, it turns into this blue thing here. Okay, now I'm going to take this 2x squared because this is going to be part of our answer, and I'm going to write it above the x squared on our divisor sign over here. Now, next step is to subtract this blue polynomial from the thing above it. So these will always cross out. That's why we make them match. We have x cubed minus 4x cubed, which will give us a negative 3x cubed, 0 minus a negative 2x squared. Make sure you keep track of your signs, is a positive 2x squared, and then we just copy down whatever comes next. Now we're just going to do the same thing over again. All right, I've rewritten this polynomial here, and we want to make this match this first one. Okay, so this time we need a negative 3x. Okay, when we multiply that in, that'll turn it into a negative 3x cubed minus 6x squared plus 3x. Okay, after that, subtract them. These always cancel. Minus a negative, so here we're going to have a plus. That'll give us 8x squared. X minus 3x is negative 2x. Copy down that 1. Okay, we have one more step. Make it match one last time. Oh, actually, before I do that, let's write this up here. Okay, so we're going to make this match one last time. So this time we just need an 8 here. That gives us this down here. And we're going to subtract it this last time. Okay, which gives us negative 18x plus 7. Right, so this 8 also goes up here. So for our answer, it's what we have up top, 2x squared minus 3x plus 8, and this is the remainder. Okay, so this is left over, and it's still being divided by what we started with. So that is what our answer would look like. Let's do one more long division because this is going to set up the next method that we use. So we rewrite it like this. It has all our exponents. We have 3, 2, x to the first, and then the constant, which is really x to the 0, because x to the 0 equals 1. Right? We want to make this match this first one. We only need 2 more x's, x squared. I'm going to write it above the x squared here. Distribute that in, x cubed plus 2x squared. Subtract those. We get negative 3x squared. Copy down that 4x. All right, repeat that process. This time we need a negative 3x. Let's write it up here. Distribute it in. Gives us that. Subtract these. 10x minus 10. And one last time. 10 goes to everything. Subtract. All right, and we get a remainder, negative 30. Okay, still being divided by that x plus 2. Okay, so we take all of those coefficients we put out front plus the remainder over what we were dividing by initially. Now this is the same problem we just did with long division. We know that the answer is going to be this down here in purple because we just did it, right? We're going to use something called synthetic division this time. It sounds complicated. It looks complicated the first 1 or 2 times that you see it. After that, you get it. It's easy. You will like it. All right, so first thing I'm going to do is I'm just going to rewrite the problem, right? So I rewrote it with coefficients in front of the x cubed and the x squared. I just put the 1s there. And I also changed this at the end here from an x plus 2 to an x minus negative 2. Same thing, it's just written differently. With synthetic division, we always need this to be a minus. So what's important when I rewrote it are the coefficients in that thing that we're dividing and what we're subtracting and what we're dividing by. Okay, so again, this has to be a minus sign, and whatever this number is important. All right, so we're going to take those coefficients from that big polynomial, 1, -1, 4, -10. We're going to take that -2 from the second, from the thing we're dividing by. And that's going to go out here. Okay, and basically we're just going to do a process. So first off, we're going to take this one and we're just going to copy it down. And this same process is going to repeat each other over and over again. So we take the -2, we multiply it with this 1, we get -2. We write it there. Okay, now we're going to add these guys together. We get -3. And then we just do this over and over again until we get to the end. So now we're doing -2 times -3. We get 6. Okay, we add these together. We get 10. Repeat one last time. -20. Add these together. -30. Now when you look at these coefficients and you compare it to what we got for our answer, hopefully you can see it without me even telling you what it is. But these are just the coefficients. We have a 1, we have a -3, we have a 10, we have remainder. Okay, we have a 1, we have a -3, we have a 10, we have a remainder of -30. So basically what we do is we just take whatever our exponent is, and that first term, we decrease it by 1, we write an x squared there, and then we just count down x squared, x to the first, x to the 0 is the constant. This is our answer. Okay, we just need to put this over the thing we're dividing by. These next two problems are all synthetic division problems. They're just asking the question in slightly different ways. So first off, it's saying factor this polynomial given that x minus 4 is a factor. So we rewrite it. It already has the minus there this time, so we don't have to change it, okay, which means that this 4 is the number that we're going to put on the outside. Okay, so we want those coefficients and that 4. We write it in our little L-shaped box, put the 4 on the outside, copy down that 1, and then we just start doing our multiplication, add them together, multiply, add those together, multiply, add those together. Okay, now here we get 0 at the end. That makes sense. It's what we would expect to get when it tells us that this is a factor. If it's a factor, it goes in evenly. There should be no remainder. Okay, now we take this, we decrease it by 1. Left over, we have 1x squared minus 2x minus 3. And it wants us to factor this whole thing. So now we look at this, and we want to factor this out. And we're just going to use earmuffs on it. Okay, so we have -3 and 1. And we can write it all as the product of 3 factors. We have x minus 3, x plus 1, and then the original factor that it gave us as the last one, x minus 4. Here we have a polynomial. It's saying that -2 is a 0. Okay, we're going to take our polynomial, grab those coefficients, and we're going to take the 0 that it gives us and put it outside that little half box. Okay, we do our synthetic division. If it tells us it's a 0, when we get to this last one, we should get 0. Okay, and it's asking us, in this case, to solve it, which means this, it wants us to find all the solutions. So we know that this is one solution, but what are the other solutions? So now we have x squared plus 0x minus 9, or just x squared minus 9. This we can factor with difference of squares. Okay, you guys tend to just write x minus 3 for this. You forget there's another parenthesis. Remember that there's 2, because if we were to FOIL this back out, it turns back into x squared minus 9. This does not equal that. This does equal this. All right, so our other two zeros, okay, actually let's write it fully factored. So fully factored, we have the x plus 3, x minus 3, x plus 2. The zeros are just if we set this equal to 0 and solve it, this would give us x equals negative 2. This would give us x equals 3. This would give us x equals negative 3. Those are our solutions.